Dear students, welcome to today's class. Today I am going to explain 2 or 3 problems which generally students made mistakes. Not only students, everybody will do, they will commit mistakes. They will understand the problems in different way. Okay now, so let us see such a type of problems. Okay, the first problem is limit extends to 0 1 upon x square minus 1 upon sin square x. What is the value of this limit of this function as x tends to 0? The function is 1 upon x square minus 1 upon sin square x. Generally, the first thing generally students they did is, as x tends to 0, 1 by x square, it tends to infinity. So therefore it is infinity minus, as x tends to 0, 1 upon sin square x, here x is in the denominator, as x tends to 0, sin x tends to 0, sin square x tends to 0, on the whole 1 by 0 is infinity. Therefore infinity minus infinity, therefore they will take it as a 0. Is it a correct answer? Is it correct answer? No. Why? Because as x tends to 0, so here we have to observe the behavior of the function 1 upon x square minus 1 upon sin square x. We have to observe the behavior of the function 1 upon x square minus 1 upon sin square x. As x tends to 0, 1 by x square tends to infinity. It tends to infinity. It is also tends to infinity, but these two infinities are not equal. These two infinities are not equal. It tends to 0. We don't know it what as you approaches to 0, 1 by x square is also tends to infinity. It goes on infinity. But these two infinities are not equal. Okay, that's why this answer is not correct. Okay now, right? This is the first approach generally students they will do. But the second approach generally students will do means, this is the first approach. However, it is wrong. Now coming to second approach, they will do like this. They will do like this. They separate the limits. Limit x tends to 0, 1 upon x square minus limit x tends to 0, 1 upon sin square x. Here what they will do, no, they multiply and divide with x square upon x square. Okay now? Multiply and divide with x square upon x square. Up to here, how much value? We know that as limit x tends to 0, we know the formula. Limit x tends to 0, sin x by x is equal to 1. At the same time, limit x tends to 0, x by sin x is also 1. Or x square by sin square x value is also 1. Therefore, up to its value is 1. Therefore, your problem will become, so limit x tends to 0, 1 by x square minus, you have to apply the limit here also, no? Limit x tends to 0, 1 by x square. Therefore, limit x tends to 1 by x square minus limit x tends to 1 by x square, both are same. Therefore, we can get cancel is equal to 0. So, this also logically it appears to be correct only. It appears to be correct. That also appears to be correct, but mathematically speaking, these two answers are wrong. Wrong. Why? Because you cannot cancel these values unless we don't know the finite values. You cannot cancel these limit values. If you know, for example, the function first function limit value is coming to be 1 by 2 minus, if the second function limit value is also 1 by 2. So these two are finite values. Therefore, you can cancel and you will get the answer 0. Understand this. Unless we don't know the, as limit x tends to 0, 1 by x square tends to infinity, limit extends to 0, the 1 by x square is also tends to infinity. Infinity minus infinity, it is an indeterminate form and we cannot determine. Understand this? So, this infinity and this infinity, they are not equal. Understand this? That's why. So, this answer is also wrong. This answer is also wrong. Okay. In the options, the 0 answer options also will be there. So, generally it is a infinity minus infinity, therefore, it is not a determinant form. So, separate the limits, multiply the numerator and denominator with x square. So, limit extends to 0, x square upon sin x square value is 1. Therefore, limit extends to 1 by x square. Therefore, both can be cancelled. So, you are getting answer means. So, logically that is also wrong. Okay now. But what is the actual and correct procedure to do this problem? Okay now. Let us see the procedure. First of all, whenever such a type of functions are given, as limit extends to 0, whatever may be that, first of all try to simplify this function, whatever may be that 1 by x square, whatever function. It is a difference of two functions. Let us make it into one function. Let us first simplify that function. I will proceed like this. Limit extends to 0. So, LCM is x square times sin square x. So, here it will come sin square x minus x square. Okay now, I have taken the LCM. In the numerator, it is in the form of a square minus b square. So, this is equal to limit extends to 0, a plus b into a minus b by x square into sin square x. Okay now, x square into sin square x. Right. Now, what I am going to do is, see here, in the denominator, I will multiply with sin square x by x square into multiply the numerator and the denominator with x square. As limit extends to 0, sin square x square by x square. This is equal to 0. Any doubt in this? X square value is 1. Yes, we have limit extends to 0, sin x by x value is 1. Therefore, limit extends to 0, sin square x square by x square is value is also 1. Anybody, anything is wrong in it? Anything is wrong? Nothing is that. Therefore, its value is equal to 1. Of course, limit extends to 0, we can apply. Now, your problem is limit extends to 0, sin x plus x into sin x minus x divided by x power 4. X power 4 divided by x power 4. Now, the problem is comes here. Now, you as extends to 0, substitute here sin 0, 0 plus 0, sin 0, 0 minus 0 on the whole numerator is 0, denominator is 0. This is of the form 0 by 0. Then you can approach the L hospital rule. But the thing is, if you L hospital rule you can do. But the thing is, if you observe here x power 4 is there. First time you have to do 4x cube, again 12x square, again 24x, again some 48 like that will come. That means almost you have to do 2-3 times you have to do the L hospital rule. That means you have to differentiate the numerator and denominator. But instead of that, use the expansions. Use the expansion. That means sin x expansion here. If you do the problem using expansion, within one step you will get the answer. Okay na? So, let us continue the solution. See here, limit extends to 0. Sin x expansion we know. Already I have given in the list of formulas, I have given sin x expansion, cos x expansion, tan x expansion. Minimum those 3 trigonometric expansions you have to learn. So, the sin x expansion is x minus x cube by 3 factorial plus x to the power of 5 by 5 factorial minus x power 7 by 7 factorial. No need of that. Only x cube by 3 factorial. Why? Because here also again you will get x minus x cube by 3 factorial. In the denominator only the highest power is 4 only. Highest power is 4. So, therefore, you can avoid the remaining highest powers of x. Okay, na? No need of writing. So, last one is plus x. Here sin x also, x minus x cube by 3 factorial minus x upon x power 4. Here x power 5, why? Because if you multiply these two, you will get x power 4, maximum you will get the answer, okay na? Right now, so you can avoid the higher powers. So here plus x minus x will get cancelled. So this is equal to limit x tends to 0, x plus x 2x minus x cube by 6. So here minus x cube by 6 divided by x power 4, x power 4. So here 1 x cube will get cancelled, x cube by x power 4, 1 x remains. This x you divide in the here and here you divide. So this implies limit x tends to 0. If you divide with here x, 2 minus x cube by x, that means x square upon 6 times minus 1 by 6. Now clearly as x tends to 0, 0 square by 6 is 0. So that is equal to, here 2 will remain, here minus 1 by 6 remains, 2 1s are 2 3s are cancelled, minus, see here x cube by x power 4, here we can cancel with the x. So this x value separate for these two terms. Here 2 will come, x cube by x. So as x tends to 0, 0 square, 0 by 6, 0. Here you will come, you will get 2. Here you will get minus 1 by 6. 2 into minus 1 by 6 is equal to 2 1s are, 2 3s are. Therefore, it is minus 1 by 3 is your final answer. Dear students, from this what you have to observe, so whenever such a type of functions are given, either plus or minus, first of all try to make this function as a single function. Don't separate the limits. So you can separate the limits, no problem. If you are getting this is also finite answer, that is also a finite answer separately, then you can separate the limits, you can find out easily. But here you are getting, so infinity minus infinity you are getting, therefore infinity minus infinity 0, no. So limit x tends to 0, 1 by x square minus limit x tends to 0, 1 by x square we can cancel, it is equal to 0, no. So you should not cancel those complete limit values, limit function limits you cannot cancel. You cannot cancel. Understand this? Right. Whenever you cannot cancel means, for example, those limits are leading to infinity or minus infinity or tends to 0, all those things are there, then you should not cancel. Okay. So this is the instead of that. So try to make the function into a single function. Okay, na? So here, if you approach the L'Hospital rule, I think it takes some time. So instead of L'Hospital rule, try to know the expansion of sin x. The problem will be very, very easy. So for your understanding purpose only, I wrote 2 or 3 steps. So even though if you didn't write these steps, you can get the answer correct. Final answer you can get easily. Okay. I hope that you understand this solution. So let us go for next problem. Welcome to this problem. Evaluate limit x tends to minus infinity, x square tan of 1 upon x whole upon root of x square 8x square plus 7x plus 1. So this is also one of the problem. Generally majority of the students or teachers, general students, they do mistakes, confusion. Okay, what is that? Generally I will proceed this problem, how to do this problem, right? Limit x tends to minus infinity, what we will do? So here tan 1 upon x is there, that means tan theta. Limit x tends to infinity, tan theta by theta, let us do that problem. Generally what the students will do now, so divide the numerator and denominator with x. Then it will become x means x is, that means x will get cancelled. So tan of 1 upon x by 1 minus 1 by x root of 8x square plus 7x plus 1. Okay, now? Right. Next step is, that means dividing the numerator and denominator with x. The next step is limit x tends to minus infinity, tan of 1 minus x by 1 minus x So this is equal to what the general we will do now. This 1 by x, take it into in the inside the root. Then 1 by x, when it goes inside, it will become 1 by x square. That means root of 8x square by x square plus 7x upon x square plus 1 by x square. Okay now. So this implies x square will get cancelled. X by x square, x1s are 1x cancel, 1 by x square. Yes, as x tends to minus infinity, whatever may be that, it is x tends to minus infinity. So this is x square get cancelled here, 8, tan of 1 by x tends to 1, tan of 1 by x by 1 by x. This value tends to 1. This value tends to 1. This value tends to 1. So here it becomes 0, it is also 0. On the whole, 1 by root 8 will come. This is equal to 1 by 2 root 2. Okay now? Right. Tan of 1 by x by 1 by x. As x tends to infinity, set you can put put 1 by x is equal to theta. 1 by x is equal to theta. As x tends to infinity, so 1 by x tends to theta. As x tends to infinity, then you can write down as x tends to infinity, theta tends to 0. Therefore, this is limit theta tends to 0, tan theta by theta. So we have the answer 1. Therefore, here x square cancels, 7 by x 0, 1 by x square is also 0. Ultimately, 1 by root 8, 1 by 2 root 2. But the answer is wrong. So here option is given 1 by 2 root 2. But the answer is wrong. Why it is wrong? Where is the mistake we committed? Everything is clear. We divided the numerator and denominator with x. Nothing wrong in it. Nothing wrong in it. Because as x is not equal to 0. X is not equal to 0. As x tends to infinity here, no, in this limit problems, no value will be equal to 0. X cannot be equal to 0. Here function is also cannot be equal to 0. So we are doing the limiting values where the function is going to approach. That value only we are observed. That means this value cannot be equal to, this function cannot be equal to, exactly cannot be equal to one value. Okay now, right. So here as per the formula, the 1 here also get root 8. So 1 by 2 root 2. Then where is the mistake committed? In which step? Either first step, second step, third step. Where is the mistake committed? So if you observe here, the mistake is committed here. That means here. Observe here, as x value tends to minus infinity, as x value tends to minus infinity, see here denominator value tends to minus infinity, that means x takes the negative values. X takes the negative values, that means 1 by negative, this will become a negative value. 1 by x means it is a negative value. When you are taking inside, you have to leave that negative outside. You have to leave that negative minus 1 outside. 1 by x only you have to. That means in the general, in the root, while taking the root, we will take a positive quantity. So the root value is always a positive. But actually here 1 by x is a negative quantity as x tends to minus infinity. So therefore x value approaches to negative values. Therefore 1 by x values also approaches to negative values. Then how can you send that 1 by x inside the function, inside the root? So that is mistake. That's why take that negativity. That negativity means what? Minus 1 outside that root and take 1 by x inside the root. So then this will become minus root 8 and your answer is minus 1 by 2 root 2. Therefore, minus 1 by 2 root 2 is your correct answer. The mistake is committed here. Here the mistake. Next step is mistake. Understand this? I hope that you understand. So your answer is minus 1 by 2 root 2. So like that, in the while doing the limit problems, so you must be very careful while applying the concepts. Okay, na? Right. I hope that you understand this concept. So let us see one more problem. Welcome to one more problem. So this also very nice problem. Generally students do mistakes. If f of x is equal to limit n tends to infinity x upon x power 2 n plus 1, where n belongs to natural number, then find limit x tends to 1 plus f of x and limit x tends to 1 minus f of x. Okay, that means here right hand side limit, here left hand side limit of 1 we have to find out. Let us see the first one. First one I will find out. That means limit x tends to 1 plus, what is your f of x? F of x is given as limit n tends to infinity x upon x power 2n plus 1. N is a natural number. Okay, now let us see, concentrate on this problem. Okay, right. Limit x tends to 1 plus, again limit n tends to infinity x upon, here x power 2n, no, I will write it as x square whole power n plus 1, just x square whole power n plus 1. Observe here, x tends to 1 plus, that means your x value here is 1, you are approaching x value from right side of 1. That means x is greater than 1. All the values which are right side of 1 are greater than 1, x greater than 1. That means when x is greater than 1, x square is also greater than 1. Am I right or wrong? X is greater than 1. Then x square is also greater than 1, obviously. When x square is greater than 1, see here n tends to infinity. N tends to infinity, here you are making into, here n is in the power, you are n tends to infinity, you are increasing the value. Here 2 square, for example x square, if it is 2 is there, 2 cube, 2 power 4, 2 power 5, x square greater than 1, no? Let us take 2. So here as n tends to infinity, so the denominator 2 square, 2 cube, 2 power 4, 2 power 5, 2 power 6. So you are making the denominator into infinity. X tends to 1, here x value is 1, you are making the denominator increasing. So when you make the denominator increasing, on the whole the fractional value tends to 0. So this value is 0. Finite value, clear. X tends to 1 plus, here x is equal to 1. 1 by, you are making the denominator infinity. You are increasing the denominator. So 1 upon, you are increasing the denominator, therefore total fraction tends to 0. Understand this problem? Okay, right. That means limit x tends to 1 plus is 0. Now coming to that problem, let us see this problem. What happens? Limit x tends to 1 minus, what is your f of x value? F of x value is given as limit n tends to infinity x upon x power 2n plus 1, as usual x power 2n plus 1, I wrote it as x square whole power n plus 1. Okay, now right. Observe here, observe this limit. X tends to 1 minus, that means you are approaching 1 from the left hand side. Okay, now that means if you observe here 0 to 1 or anything, you will get fractions here. 0 from 0 to 1 you will be getting fractions. Otherwise if you come here, you will get negative values you are getting. Okay, now that means this x square value, x value is less than 1, on the whole x square value is also less than 1. If x value is less than 1, x square values is also still they are less than 1. Now, n tends to infinity. N tends to infinity. If you observe here, n tends to infinity means you are increasing this value, negative less than 1 value you are increasing, making powers rising. So when you are making powers rising, what happens? This value tends to 0. That means, for example, less than 1 means if you take 1 by 2, less than 1 means you take 1 by 2. You raise the powers, as n tends to infinity, 1 by 2 whole power n tends to 0. Tends to 0. Understand? It is a fraction, lies between 0 to 1 or less than negative values. As the power increasing, this 1 by 2, 1 by 4, 1 by 7, 1 by 8, minus 1 by 5, minus 1 by 3, minus 2, minus 7, they are all approaches to 0. That means, as x tends to 1 minus, here it is 1 by, this value is 0 plus 1, on the whole your answer is 1. Okay now? Right. So, limit x tends to 1 plus f of x, it is 0. Limit x tends to 1 minus f of x value is 1. Okay now? So, like that you have to think in a logically you have to think. Okay. So, a very, very nice problem. The only thing is x square whole power n, as x tends to 1 plus positive side, x square is also positive side, it is going on increasing means x square whole power n value is also going on increasing. 1 upon the fraction denominator is going on increasing. One finite value upon denominator is going on increasing. Therefore, the total fraction approaches to 0. But here x tends to 1 minus means the x value is less than 1. Therefore, x square value is still less than 1. That means it will become some proper fraction. So, the proper fraction whole power n is a natural number, already is given, n is a natural number. If it go on, n is a natural number. If you go on increasing, total fraction value tends to 0. Okay na? So, this is tends to 0, this is a 1 in the numerator, obviously it is 1, 1 upon 0 plus 1, this is a 0. Okay na? I hope that you understand this problem. Here one of the very nice problem which was asked in one of the JEE advanced examination. Limit m tends to infinity times limit n tends to infinity cos to the power of 2m n factorial into x into pi, where x is a real number. Then prove that f of x is equal to 1 if x is a rational number, 0 if x is irrational number. Of course, it was given in an optional form, we converted into in a problematic way. Right, observe here, this function value is, here your x is here. See here, your x is here. This is your x. So, if your x value is rational, then the total function value approaches to 1. If your x value is irrational, then total function value will become 0. Will not equal to 0, of course, it approaches to 0. Then how to solve this problem? Okay, right. Let us see the solution. First, here it is given x is a rational number. Let us see that x is a rational number. Case 1. X is rational. Right. When x is a rational number, we know that every rational can be expressed of the form p by q, where p, q are integer and q is not equal to 0. That everybody knows the definition. Then observe what happens this value. That means n factorial into, in place of x, p by q into pi. Then what happens this value? Of course, afterwards I will tell what is meant by cos to the power of 2 pi. Cos to the power of 2m, this angle theta. This is the theta angle. Then what is the theta angle? If you observe, if you see this, what will be this value? Can we cancel n factorial and q? n factorial and q can we cancel? Yes, we can cancel. N factorial means what? N is, of course, n is a natural number. N factorial means what? For example, if you take 5 factorial, 5 factorial, if you take 5 into 4 into 3 into 2 into 1, then we can find out a q value which can be cancelled. If it is some 10 factorial, 10 into 9 into 8 into 1, any one of the value 1, 2, 3, 4 up to 10, we can choose the value and we can cancel. Then this will become an integer. We can make it as an integer. We can cancel n factorial and q. N you take any number, some 10 factorial, 20 factorial, 30 factorial, 30 into 29 into 28 into so on, 3 into 2 into 1. We can choose one number q such that it can be cancelled. For example, if I take 28, 28, 28 we can cancel. Remaining all integer, no. P is also an integer. It is an integer, integer, integer into integer, integer. Therefore, integer into pi. On the whole, it is an integral multiple of pi. Multiple of pi. On the whole, this angle is an integral multiple of pi where k is an integer. So, n factorial into x into pi, when x is a rational number, n factorial into x into pi is an integer, right? When it is an integer, let us see this problem. So, limit m tends to infinity. So, limit n tends to infinity. See here just a bracket, it is not a fractional part function unless otherwise given. Don't think that this flower bracket has a fractional part. It is not a fractional part, just a bracket, that's all. N tends to infinity. So, this is equal to cos power cos square. This is integral multiple of pi whole power m. So, here cos power 2m, no. So, I can write down cos square whole power m, a power m whole power m, a power mn. Now, what will be your answer? Cos k pi is always plus or minus 1, where k is an integer, that we know from trigonometry. Cos k pi is always plus or minus 1, cos pi minus 1, cos minus pi, again pi, 1 plus 1, like that it will go. That means this value is plus cos k pi value is plus or minus 1 whole square. Plus or minus 1 whole square means 1, that is 1 to the power of, that means limit m tends to infinity, m tends to infinity. So, this whole thing will become 1 power m. M tends to infinity, 1 power m. So, 1 to the power, how many times you can raise? This value is 1. That's all. So, when x is a rational number, x is a rational number, as x is a rational number, then this is the process you will get. As n tends to infinity, as n goes on increasing, here it is given n tends to infinity, that means n is a, if you, as long as you will take 100 factorial you will take, we can take one q value such that it can be cancelled. You can cancel with that. That means n tends to infinity. In fact, if you take 1000 factorial, 1000 into 999 into like that. So, we can take some 1000 will get cancelled. Therefore, you will get an integral factor, integral multiple of pi. Therefore, cos k pi is plus or minus 1 whole square is equal to 1 to the power of m, as m tends to infinity. So, here the base is 1. So, therefore, 1. So, therefore, irrational number, rational number. When x is a rational number, your functional value approaches to 1. Okay? And I hope that you understand this problem. Now, let us see what happens if x is irrational number. So, let us see that case 2. Case 2. When x is irrational number, what happens? Then definitely n factorial into x pi, it is also, it cannot be equal to k pi. Definitely, when it is a x is a rational number, then you can, it will be an integral multiple of pi. When x is not an irrational number, definitely you won't get an integer. Quite opposite. When it is not k pi, then cos k pi. This cos k pi, it is not equal to plus or minus 1. Plus or minus 1. Therefore, cos square k pi, it cannot be, it is not equal to 1. Cos k pi is not equal to plus or minus 1. Therefore, cos square k pi is not equal to 1. We know that 0 less than or equal to cos square k pi strictly less than 1 at that situation. Cos square k pi is strictly less than 1. Why? Because it cannot be equal to 1. Now coming to your problem. Our problem, limit m tends to infinity, limit n tends to infinity. This is equal to cos square. This value lies between 0 to 1. The value lies between cos square k pi value lies between 0 to 1 means what? It is a proper fraction. 0 to 1 means what? Proper fraction. That means cos square n factorial into exponent 5 is a proper fraction. Proper fraction whole power m. See here, proper fraction means what? 1 by 2, 1 by 4. If you are goes on raising the powers, for a proper fraction, this power m, if you goes on raising, total value approaches to 0. Just a previous problem also I explained. It is a proper fraction, 1 by 2, 3 by 4, 7 by some 8, proper fraction. If the power is increased here, that means proper, m tends to infinity, no? M tends to infinity. That means proper fraction whole power m. This m is tends to 0. M is tends to infinity. Total this fraction tends to 0. Proper fraction whole to the power of m. M value power raises to infinity. Total value approaches to 0. Okay na? So dear students, I hope that you understand these concepts. I hope that you enjoyed today's class. So in limits chapter, you should be fundamentally strong with all the basics concept. So with some more problems and some more concepts, and tomorrow's class, I will come before you. Until then, all the best.